Hello everyone, welcome back to WAPC. Right now, we are going to discuss about the previous year questions in Kcet exam. Okay, here is our first question. Which noble gas has the least tendency to form compounds? Okay, which one would be argon, krypton, helium, or neon? Okay, so in this thing, we could only say that helium has the least tendency to form any such kinds of compounds. Okay, because this is due to the fact that it is in small size and high ionization energy. Okay, which makes it very unstable and stable and unreactive. Okay, so for this, the correct one is helium. Okay, helium is the noble gas that does not form any compound. Okay, our next question is the correct IUPAC naming of cisplatin. Okay, cisplatin. How can we draw cisplatin actually? Well, it is a cancer regarding drug actually. Cisplatin. So for this we could write, which is the central metal atom is platinum along with NH3 twice and Cl2. Okay. This is cisplatin, okay, and the structure of cisplatin would be like this. Cl, okay, this is cisplatin. So the IUPAC naming for this system would be diamine. There are two amines, dichlorido, platinum 2, right? Because the oxidation state of platinum is positive 2, right? So the correct option would be option 3, diamine dichlorido platinum 2. Okay, and our next question is, which of the following chlorohydrocarbon readily undergoes solvolysis? Okay, this is our next question. Which of the following does undergo solvolysis? Well, to explain this solvolysis, we have to first consider the fact that on solvolysis, it only gives stable carbocations, right? Only stable carbocations can give solvolysis. In this fact that we could write that this cannot form a stable carbocation, chlorobenzene, and this can't even. This is due to the fact that the adjacent double bond present in. So pi electron cannot withstand the positive electron right down there. So both the option C and D cannot form solvolysis. Okay, and we could say that on this option, regarding option 2 and 1 can form CH2 plus, right? See, this is a stable carbocation. This is the fact that there are two. It's a primary. Regarding this, there is a secondary carbocation. But in the case of this, they are primary carbocation. So the most stable would be CH2Cl. So the correct option would be option A, benzoyl chloride. Okay, and whether by moving on, we have our next question. In oxygen and carbon molecule, the bonding is, okay, 42nd question, the bonding between in oxygen and carbon molecule, that's what we are discussing right here. Well, oxygen molecule contains 1 sigma bond and 1 pi bond. Okay, but in the case of a carbon molecule, okay, C2 molecule contains 2 pi molecule. Instead of a sigma molecule, it contains 2 pi bonding. Okay, so the correct option would be option 1. Our next question is a secondary amine. Okay, a secondary amine. You do know what is a secondary amine, right? A secondary amine is a compound with NH2 group on the carbon atom in number 2 position. A compound with which 2 of the hydrogen of NH3 have been replaced by organic compounds. Okay, An organic compound with 2 NH2 group. Okay. And a compound with NH2 with 2 carbon atom and an NH2 group. So what would be the correct answer for this one? A secondary amine. Okay. Can have any guesses right down there? Well, what is a secondary amine? It's actually an alkyl group instead of an 2 alkyl group instead of the both the hydrogen. Okay. So this is a secondary amine. Well, in a compound with NH2 group on the carbon atom, this is wrong. First one is completely wrong, right? A compound in which 2 of the hydrogen of NH3 have been replaced by organic groups. Well, we could say like that, right? It is replaced by the both alkyl groups. Oh, so that it should, option 2 is correct. An organic compound with 2 NH2 group. Well, what is an organic compound with 2 NH2 groups? It is hydrazine. So this is wrong. Okay. A compound with 2 carbon atom and an NH2 group. Well, that is completely different node. So the correct option would be option 2. Our second question is, the work done when 2 moles of an ideal gas expands reversibly and isothermally from a volume of 1 liter to 10 liter at 300 Kelvin temperature. Well, we have given the universal gas constant value of 0.0083 kilojoule Kelvin per mole. Okay. So regarding this, we have to find out the work done. It's a simple equation and it's a simple question. We could answer it easily. Well, W is equal to, we could write minus 2.303, okay, nRT, right, nRT log V2 by V1, okay. Well, minus 2.303, well, there are 2 moles, okay, into 2 into 0.00821 into 300, right, into log V2 by V1. Well, V2 is 10 by 1, log 10 is 1, okay, and by that we could say that 2 upon 3, which gives almost like 11.5 kilojoule. This is correct actually. Well, calculate and look into that. It's option number 3, right. We have found out the work done during the expansion of 10 liter from 1 liter to 10 liter, okay. And we will move on to our next question. Which of the following is correctly matched? Okay, bakelite or novolac, polyester tetrafluoroethane, okay, nylon and acrylonitrile, and teflon and caprolactam. These are the following, and we have to find out the correct option from this. Okay, bakelite and novolac. Okay, so the correct option from this equation might be bakelite and novolac. All right, bakelite and novolac. Actually, what is bakelite here? How could you explain a polymer bakelite here? Bakelite is actually the thermosetting polymer, okay, not a thermoplastic. It is formed by the polymerization of phenol and formaldehyde, okay, and cannot be remolded. So bakelite is it cannot be remolded after it has set. So therefore, bakelite and novolac is also a thermosetting polymer, and which cannot be remolded. So both bakelite and novolac are the same thing. So the correct option would be bakelite and novolac, option 1. Okay. On moving on to the next question. The general name of the compound formed by the reaction between aldehyde and alcohol. Well, on reaction with the aldehyde and alcohol, we could get an acetal, right? Have you heard any about acetal? It's nothing but reaction between an aldehyde. Well, consider this reaction, right? When an acetal CH3, C double bond O H, this is our aldehyde. When this is treated with our alcohol CH3CH2OH, ethanol, we get an hemiacetal, right, which is nothing but CH3 we have CH3 here and H out of here, OH, and this bond is bonded with O along with CH2 CH3. Okay, this is an hemiacetal, and further addition of an alcohol to this molecule, we get an complete acetal. So we get CH3 OH, okay, O CH2 CH3. Okay, this is then treated with what? An alcohol, right? We get CH3 HOCH3 with OCH3. Yes, sorry, there's a slight mistake here. It is OCH3. So this is an acetal, right? Fine, we have completed this reaction. So on treatment with aldehyde and an alcohol, we get an acetal, option 4. Okay. On moving on, we have a strong reducing property of hypophosphorus acid is due to the fact whether it is a 2 pH bonds or a presence of a phosphorus in its highest oxidation state. Okay, its concentration or the positive valency of phosphorus. Okay, well, before answering that, we might answer some of the H3PO4. Okay, questions regarding H3, orthophosphoric hypophosphorus acid. Okay, sorry, this is orthophosphoric acid. I am going to explain about hypophosphorus acid. Okay, well, hypophosphorus acid contains 2 pH bond. That's what it makes him much more reducing character. Never happens on the oxidation state. Okay, oxidation state is on the highest. It does not affect that much, and concentration is an absurd answer. It does not depend upon the concentration. Okay, moving on over to next question. The complex hexamine platinum 4 chloride will give dash number of ions. Okay, this is our question, 15th. Okay, which hexamine? Okay, to answer this, we must write the equation of hexamine platinum 4 chloride. Okay, hexamine, there are 6 amine in this group. Okay, 6 amine, platinum, okay, a chloride on the right side, right? Yes, Cl4. Okay, and upon ionization we get PtNH3 6, okay, 4 minus, right? Sorry, 4 plus and 4 Cl minus. So upon ionization, platinum hexamine chloride gives 4 ions. Okay, so sorry, there should be number of ions. Okay, so there are total 5 ions, right? Yes, 5. There are total 5 ions. Okay, 5 ions. Okay, our next question is the property of halogens which is not correctly matched is which of the following actually? Electron density or electron gain enthalpy, or ionization enthalpy, or electron negativity. For which of the following? For this, the electron affinity for chlorine is maximum. We have concluded that the electron affinity of chlorine is maximum. We have studied in the periodic table, classification of periodic table chapter, and upon doing that, we noted that the current trend for electron affinity would be chlorine. Okay, then comes fluorine, then bromine, then iodine. Okay, electron affinity in which the electronegativity becomes fluorine, electron affinity, right? This is electron affinity. Electronegativity gives fluorine, chlorine, bromine and iodine. Okay, well, electronegativity of an atom increases down the group, right? So which is the topmost fluorine, then comes chlorine, then bromine, then iodine. Okay, this is the current trend in the increase in ionization enthalpy. Sorry, electronegativity. Okay, well, there's a slight mistake in this. You should never do this on here. So we should fluorine electron gain enthalpy, right? Option 2, electron gain enthalpy, right? Electron gain enthalpy. Okay. Sorry for that misunderstanding. It's electron gain enthalpy. Okay. All copper 2 halides are known except the iodine. The reaction for is that. What would be the reaction? Okay. Well, we have to find out why copper 2 halides are known except for the iodide. Okay. For there are two oxidation states in copper. Copper plus 1 and copper plus 2. Okay. These are the two oxidation states. And the halides of copper can be represented by CuX2. Okay. CuX2, and where X may be the halogens like chlorine, bromine, iodine. Okay. And for this we have to find out the formation of CuI2. Okay. Well, it exists in the plus 2 oxidation state. For that we can write like this one. Okay. CuI2 upon gives Cui plus I2. Right. This is the dissociation of copper iodide. Okay. Iodine gas is liberated and the copper iodide is formed. Okay. From this process, this decomposition accompanies with the oxidation of iodine ion. Okay, to form an iodide element. Okay. It indicates that the presence of Cu2 plus leads to the oxidation to I2, which is one of most characteristics of a stable halides. Okay. For that we could conclude that the instability of CuI2 is primarily due to the oxidation of iodine ions by Cu2 plus. Okay, we have discussed this earlier, leading to the formation of Cui and the liberation of iodine gas. Therefore, CuI2 does not exist as a stable compound. So the correct option would be the option 4, right? All Cu2 plus 2 halides are known except the iodide because of CuI2 is unstable and decomposition from Cui with Cu2 plus oxidizing the iodine solution. Sorry, the iodine ions. So the correct option would be option 4, right? Am I right about this one? Okay. Cu2 plus oxidizes iodide to iodine. Okay. This is what happens in copper iodide solution as a copper 2 element. Moving on, we have the half-life of a reaction is found to be inversely proportional to the fifth power of initial concentration. The order of the reaction is, okay, we do know that the half-life, okay, half-life, where half-life is given by T half, okay, T half of a reaction is found to be inversely proportional to the fifth power of its initial concentration. Well, we can write like this: initial concentration A0 by fifth power. Okay, is it fifth? Yes, to the fifth power initial. The order of the reaction is, we have to find out the order. Okay, well, we also know that T half is directly proportional to A0 by 1 minus n. Okay, A0 by 1 minus 5 is equal to 1 minus 5. Okay, okay, we have found out this one when minus 4 is equal to 1 minus 4 is equal to, okay, minus 4 is equal to minus n, and okay, sorry, minus 4 is equal to 1 minus n, n is equal to 5, right? So the half life of a reaction is inversely proportional to the fifth root of initial concentration. So the order of the reaction would be 5. Okay, so the correct option would be option A, which is 5. Am I right for this question? Yes. actually 6. There's a slight mathematical error here. N is equal to 6, which is 6th, option 2. Okay, 6th power. Order of the reaction is 6. Moving on, we have elements X, Y and Z. Okay, have atomic number 19, 37 and 55 respectively. Which of the following statement have the is correct about them? Okay, 41 or we could say Z would be the highest ionization potential. Let me check on that one. Okay, why would be the highest ionization potential? The ionization potential would increase with increasing atomic number. Y would have an ionization potential between those of X and Z. Okay. To this we can say that the elements with these atomic number, okay, they are alkali metals. Okay, the 19, 37, 55 are actually alkali metals within the group. So in that trend we could say that the ionization energy decreases from top to bottom. Okay, we have studied in the periodic table classification that the ionization energy of elements decreases from top to bottom in a periodic table. Therefore, in saying that X could be the Z cannot be the highest ionization energy. Y could not have the highest ionization energy. The highest ionization energy depends on the X. So it's actually X has the highest. There is no option for that. And the correct option would be Y would have an ionization potential between those of X and Z. Okay, it is true actually, and it is true. Their ionization potential would increase with increase in atomic number. That cannot be particularly true actually. So it does not increases that way. It increases from top to bottom in a periodic table. Okay, so this is also wrong. The correct option would be 4, which states that Y should have an ionization potential between those of X and Z. Okay, we'll move on to our next question. Which is the most viscous? Okay, which is the most viscous? Viscosity in such compounds depends upon the hydrogen bonding. Okay, hydrogen bonding makes depends or intimates the viscosity in any compounds. So we should find out the intramolecular hydrogen bonding or intermolecular hydrogen bonding in these 4 compounds. Okay, methanol, okay, ethanol, okay, glycerol, right, this is glycerol, okay, and we have stopped it. The intermolecular hydrogen bonding in both these compounds is very much less, because there is no any other hydrogen present in, there is no intermolecular or intramolecular. The only hydrogen bonding that are present in between is these 2 hydroxyl group in glycerol. Okay, this helps in the hydrogen bonding and strengthens the bond between those 2 hydroxyl groups and makes it most viscous. So the correct option for this question would be glycerol, which is option 2. Glycerol is the most viscous compound. Okay, the extent of hydrogen bonding is more in glycerol. Our next question is the volume of 2.8 gram of carbon monoxide at 2.8 gram of carbon monoxide at 27 degrees Celsius and 0.821 atmospheric pressure is dash. Have to find out the volume. Okay, yes, we have to find out the volume. Okay, well, upon giving this, we should find the number of moles of carbon monoxide. Okay, N of CO is given by molecular mass. Okay, to given mass by molecular mass. Well, molecular mass of carbon monoxide is given by 28. Okay, we do know that it's 28. 12 plus 16, 28. Okay, which gives 0.1. Okay, 0.1 moles of carbon monoxide. Okay, upon this, we have found the number of moles of carbon monoxide. have to find out using the universal ideal gas law. Okay, using ideal gas law, we could find out that PV equal to nRT. Okay, PV equal to nRT. Well, V is equal to nRT by P. Okay, we have found out the number of moles in carbon monoxide, which is 0.1 into the universal gas constant value, which is 0.0821. Okay, and at a temperature with 27 degrees Celsius, which is 300 Kelvin, right? Because we could not express in Celsius, we have to use it in Kelvin. 27 plus 273, which gives 300. Okay, by pressure at which 0.821. Okay, we could cancel out these in here itself. Okay, we could cancel out 0.1. Okay, 0.1 into 0.1 gives 0.01 into 300, which gives us 3 liters. Okay, so the correct option for this question would be 3. Okay, is there any option like 3? Yes, we have option number 1, 3. Okay, the volume of the gas liquid found to be option 3. Sorry, option 1, which is 3 liters. Okay, moving on to the next question. Yes, in Cope's reaction, the reacting substances are sodium phenate and carbon tetrachloride, phenol and CHCl3, sodium phenate and carbon dioxide, phenol and carbon tetrachloride. We all do know that the reaction of a Cope's reaction is sodium phenoxide, okay, ONA, along with carbon dioxide. This is the reaction. Okay, these are the reactants used for Cope's reaction. Okay, which upon gives, like, when they are treated with, we get an salicylic acid. Okay, OH, COOH. Okay, this gives a salicylic acid, upon which we treated with HCl or SnCl2. We get salicylaldehyde. Okay, which have highly medicinal purposes, salicylaldehyde. So the correct option for this question would be sodium phenate and carbon dioxide, option 3. Well, we shall move on to the next question. Reaction in which benzaldehyde cannot be prepared. Okay, benzaldehyde. We do know that in the first option, toluene. Okay, toluene when treated with CrO2Cl2 in CS2, we get benzaldehyde. Okay, this is actually a method for preparing aromatic aldehyde. So option 1 is correct, and benzoyl chloride on H2 in palladium barium sulfate. Okay, benzoyl chloride, which means C6H6 COCl in palladium over barium sulfate. Okay, this also gives benzaldehyde. What do we name this reaction? We have earlier studied this reaction actually, palladium over barium sulfate. This is actually nothing but Rosenman reduction. Okay, so option 2 is Rosenman reduction, which is also true. Benzene on COHCl, benzene on carbon monoxide. Okay, our next option, benzene on carbon monoxide and HCl, which gives benzaldehyde. Sorry, which also gives benzaldehyde. This is also another named reaction, which is Ettart's reaction. Okay, Ettart's reaction. So option 3 is also feasible, and the only thing that cannot form an benzaldehyde is this. Okay, benzoic acid on treatment with zinc mercury amalgam. Okay, this ZnHg is actually a zinc amalgam. it does not form, it does not form benzaldehyde. So option 4 is the correct one. Option 4 is actually the Clemmensen reduction reaction. Okay, it reduces benzoic acid to ketones or some other products. So option 4 is the correct answer. And let's move on to our next question.